This is problem 3 from practice exam 1 of module 6 in the book Problem Solving Guide for Mechanics and Thermodynamics. We have an 8-gram bullet shot at a 1.5 kilogram steel disc. Showing from the top in this figure, after the collision, the bullet ricochets off 25 degrees above the original line of the bullet at 200 meters per second. The disc was at rest. It goes down at 55 degrees below the horizontal, not given the speed of the disc at all. We need to know the original speed of the bullet. Let's label the givens. The mass of the bullet, 8 grams. After the collision, the bullet's going 200 meters per second. Still has a mass of 8 grams. The puck, which is the disc, which is 1.5 kilograms, is going 55 degrees below the horizontal, but we don't know its speed. So we have two unknowns: the initial speed of the bullet, final speed of the disc. We need two equations. We shouldn't assume that the collision is elastic unless it tells us it's elastic. So if you write the conservation of energy equation, we get another equation, but we also get another unknown. So we're going to have three unknowns: initial speed of the bullet, final speed of the disc, thermal energy generated. So that's not going to help. Let's move forward with momentum only and see what happens. If we need something else, we'll address it then. We can do some calculations. Momentum is a vector, so it's conserved in all directions. If we define the x-axis horizontal and the y-axis vertical, we can write the conservation momentum in the x direction. P initial x equals P final x. P initial x before the collision is only the momentum of the bullet. It's 8 grams times the speed of the bullet, which we do not have. The final momentum in the x direction is the horizontal component of the momentum of the bullet, 8 kilograms times 200 meters per second cosine 25 degrees. Converting the 1.5 kilograms to grams, we have 1,500 grams times v final of the disc cosine 55 degrees. That is the final momentum. This reduces to, we know what the bullet is in the x direction, 1450 gram meters per second. And we don't know what this final speed of the disc is, so we can't calculate a number for the final momentum in the x direction, but we can set it equal to the initial momentum in the x direction. It gives us this. We have two unknowns. We need another equation, and we can get that because momentum is a vector. We can use the y direction. P initial y equals P final y. What's the initial momentum in the y direction? It's 0. The final momentum in the y direction must be 0 because the initial momentum in the y direction is 0. So 0, that's the initial momentum. This is positive. The bullet's moving up in the y direction. 8 grams times the speed times sine 25 degrees. That's the vertical component. The disc is moving downwards. 1,500 grams, v final disc, sine 55 degrees. And these two momentum vectors must be equal and opposite because there is no momentum in the x direction initially. So we can solve for that, and we have an unknown over here, v final disc. One equation, one unknown. We can solve that. The steel disc must be moving at 0.55 meters per second after the bullet ricochets off of it. We can substitute this back into the conservation momentum in the x direction. So now we know what this is. It's 0.55 meters per second. We have the final momentum, so we can get the initial momentum in the x direction. Divide both sides by 8 grams, and we get 240 meters per second for the initial speed of the bullet. Let's check this. We got the answer, but let's check it. The initial momentum in the system is 1920 grams meters per second to the right. It's all in the positive horizontal direction. The final momentum of the bullet is this. Now we have to get the components. The horizontal component is 1450. The vertical component is 676. This is final. The final momentum of the disc is that, but now we got to get the components. 55 degrees below the positive horizontal axis. The horizontal component is 470. And the vertical component is 676 down. So let's put these momentum vectors on a diagram. These are components of the vectors. There's the initial momentum. It's 1920, only the bullet. The final momentum has x and y components of each. Looking at just the bullet, we got 676 up and 1450 across. The disk is 470 across, 676 down. The total final momentum, we have 676 grams meters per second up, 676 grams meters per second down. That's 0. We have 470 in the x. We have 1450 in the x for the bullet, 470 for the disk. We add those up, we get 1920. Sum up these two vectors and you get that, and that is the initial momentum vector. Ta-da!